Hello everyone. Today we're talking about using trig identities in order to simplify trigonometric equations. The following trig identities we've talked about or we've referenced in the past, mostly back in January with our unit circle construction. But now we're organizing them as tangent and cotangent fall under the quotient identities, whereas cosecant, secant, and cotangent fall under the reciprocal identities. We've also talked before about Pythagorean theorem and Pythagorean identity, and from that Pythagorean identity, it is possible to derive our tan squared theta plus 1 equals secant squared theta, and our cotangent theta plus 1 equals cosecant squared theta. I'm not going to ask you to derive these things. That would be for our dual credit students. And then our even and odd identities, building off of the idea that some functions like x squared are even, while some functions like x cubed are odd, merely showing you which of the trig functions are even and which ones are odd. Now, the identities on this page and the previous page, you do not need to memorize them. I have not memorized them for the most part. Well, no, I've memorized the quotient and reciprocal identities, but that's just because I teach the subject. Pythagorean identities, the even odd identities, you don't need to memorize. You can have those sheets out when you're working these problems. No worries on that. Now, why am I bringing these back up? Well, for this next unit, or this next segment of our units, we're going to be using these identities to rewrite and prove different trigonometric equations. So functionally, we are going to simplify trigonometric expressions as well as establish new identities. In this video, I will cover number 1 and number 2. I will make a separate video for numbers 3 and 4. Now, there are going to be multiple ways to solve these problems. The way that I do it is not necessarily the only way, it's just the way that makes the most sense to me. Trig identities are hyperlogical. So if you're good with logic, if you're good with a matter of fact flow of steps, this should be fundamentally easy for you. If not, that's fine. Practice will help you with these problems. So let's take a look at the first one. Cotangent of x divided by the cosecant of x. So, zooming in to give myself a lot of room. Let's start off with what's given to me. The cotangent of x divided by the cosecant of x. And that's just given. That's the problem as it's set up. Now, I want to substitute things that I can work with. Ideally, I want to move things into sines and cosines if I can. Or if not, I at least want to get rid of any sort of fractions. So to do that, I'm going to replace my cotangent x with the quotient identity of cotangent, which is my cosine of x divided by my sine of x, and I still have underneath that divided by my cosecant of x. I'm able to do that because of my quotient identity for my cotangent. I'm then going to replace my cosecant x with my reciprocal identity of sine x, such that I now have cosine of x divided by sine of x divided by 1 over sine of x, thanks to my reciprocal identity of cosecant and sine. Now, I've created a situation where I have two fractions being divided by each other. I can then use my division of fraction rule to change the order of this equation to cosine of x over sine of x divided by 1 over sine of x. And that's just from our division rules. When we're dividing fractions, we can also multiply by the reciprocal. So instead of dividing by 1 over sine x, I can actually just multiply instead by sine x over 1. So multiply by sine x over 1. Now we see that I have in my numerator a sine x and my denominator a sine x. So I can cancel them out. And that leaves me with just cosine of x, thanks to simplification. So I took my funky looking cotangent of x divided by cosecant of x and re-expressed it, simplified it using my identities into merely cosine of x. Let's look at number 2. Bit of a longer one here, but that's fine. I want to simplify this as much as I can, starting off with 1 plus sine of x divided by sine of x. And I'm going to add to that cotan x minus cosine x divided by cosine x. Looks like a lot, but it is perfectly manageable. So let's start with what's given to us. 1 plus the sine of x divided by the sine of x plus the cotangent of x minus the cosine of x divided by the cosine of x, and that's just given to us. If you recall from middle school, whenever we're dealing with fractions that have an operation of addition or subtraction in the numerator, but are over a single denominator, we can expand our fraction such that the operators are instead between fractions. So I can turn this set of 2 fractions into a set of 4 fractions. I know some of you might be thinking, why would I do that? That's adding to the complexity. We're going to make it more complex slightly so that it becomes simpler in the end. Sort of a 1 step back, 2 steps forward situation. So I've got 1 over sine of x plus sine of x over sine of x plus cotangent of x over cosine of x minus cosine of x over cosine of x. I got that just from expansion. Or expand. Well, I've got a few things here I can work with. Whenever I have a numerator denominator that are both the same, like I here with sine x over sine x, or cosine x over cosine x, I can actually simplify that down to 1. So that would give me 1 over sine x plus 1 plus cotangent of x over cosine of x minus 1. So we simplified. Well, plus 1, minus 1, they'll cancel out. So that just gives me 1 over sine x plus cotan x over cosine x. Again, simplifying. Well, 1 over sine x, I know that to be a reciprocal identity. 1 over sine x is the same as cosecant x. So cosecant of x plus cotangent of x divided by the cosine of x. And that's going to be a reciprocal identity. Cotangent of x, I want to see if I can rewrite that in terms of cosine and sine. Well, I can. I still have my cosecant of x, still have my plus, still have my divided by cosine of x, but now I'm going to rewrite my cotangent of x using my quotient identity into cosine of x divided by sine of x. So that's going to be my quotient identity. All right. Now, technically, all numbers are always being divided by 1 and multiplied by 1. So this cosine of x in the denominator, I'm just going to put it over 1. I haven't changed anything, but that just helps us see that here we have two fractions being divided against each other. So we can use that for our next step. I'm still going to have my cosecant of x plus, stick my parentheses because we're doing some division here, cosine of x over sine of x divided by cosine of x over 1. That's just going to be division rules. But whenever we're dividing by fractions, we can multiply by the reciprocal of the second. So instead of dividing by cosine x over 1, I can instead multiply this by 1 over cosine x. This then allows me to cancel out my cosine x's and leaves me with 1 over sine x. Yeah, we'll stick to blue. So then I have my cosecant of x plus 1 over sine x. That's from simplifying. 1 over sine x, I know that's going to be my reciprocal identity. So I now have cosecant x plus cosecant x. Again, that's going to be my reciprocal identity. Cosecant of x plus cosecant of x, that's just 2 cosecant of x. Simplified. So I took my giant fractional bit and simplified that down to 2 cosecant of x. While it isn't in terms of sine or cosine, it is without fractions. So if we can't get things in terms of sine and cosine, we should at least be able to remove our fractions. Please check the next video for 3 and 4.